Right, good afternoon, ladies and gentlemen. I'm going to try and speak very slowly today. I've been given my instructions. So I've been asked to continue the theme of feeding horses forage today and looking at the forage quality and the health of the horse. And I'm a strong believer in the fact that feeding is not a short-term fix for anything. Many people in the UK, particularly racehorse owners and people who are doing performance horses, want me to tell them how to feed their horse to make it run faster. It's not possible. It's a combination of feeding and exercise and genetics and training. You can feed to make sure the horse is in the optimum condition to give you his best performance, but you can't make him run faster by feeding him. You can make him run slower by feeding him badly. So feeding is a long-term provision of nutrients that maintains ideal mind and body condition and supports the demands of work. So it's a long-term process. And when we start to think about feeding horses, we must think about the gastrointestinal anatomy. And I always think of this in a diagram, in a shape. So for me, it's a triangle on its side. The stomach is very small. It's only 8 litres capacity. Then the small intestine is long, but very thin, and the food goes through there very rapidly. You can feed a horse any concentrate or any meal feed, and it will be through the stomach and the small intestine, sometimes within 40 minutes. So we've measured rate of passage and how quickly it goes through there. So you've got to be aware of what you're feeding when it goes through the small intestine, that you've only got a limited time for the animal to digest food within that particular part of the gut. But the main thing is the hindgut. Now the hindgut is the largest part of the gastrointestinal tract. It is 30 litres capacity, and it contains the most important things in nutrition, or in the horse's gut, that helps the animal get the best out of its food. So we've got lots of these little things. I always say to my students, if we feed the bacteria and the protozoa and all the yeasts, they are what deals with the feed, and then they produce the end products that the horse can use for energy and to keep itself healthy and alive. So we need to feed, we need to think about feeding the hindgut, feeding the live microbiome, the live microbial population in the hindgut. And with all of that in mind, we've got to be aware of the rate of passage of food, so how quickly it goes through different parts of the gut, and also what will influence that. So it's not just the speed of the food going through and how digestible it is, it's also the concentration of glucose and fat in the bloodstream that will determine how much the horse will eat. So to keep these little chaps happy in the hindgut, you've got to feed quality fibre. There is no alternative but good quality fibre to make sure that the animal's hindgut is healthy. So what do I mean by quality fibre? Well, you should feed a minimum of 1.5% of the body weight per day as fibre. That's a recent regulation of the best level which maintains gut health in the horse. And the quality fibre I'm talking about is grass. There's nothing wrong with grass. If you can grow some good grass, and there must be regions in Mexico when you can grow good grass, then let the horse eat the natural diet. Hay can be good quality or not such good quality. This is a slightly more fibrous and less good quality hay that is sometimes made in the UK. And you can see that it's rather yellow in colour, and it looks rather stalky, and therefore it's of low nutritional value. This is a better quality hay. It's greener and it's got more leaf to stem ratio. Then we also feed haylage, and I said a little bit about haylage yesterday, which is the in-between of hay and of silage. And we make it in these big bales, so it's cut, it's allowed to dry for 2 days maybe. It's baled into these very large round bales, and then it's wrapped in plastic, and it ferments. And it's very high quality and very rich in energy and protein, can be. We've also got some proprietary feeds, so quite a few companies in the UK actually make haylage and sell it in 20 kilogram bags to people with only 1 or 2 horses. Again, very high quality forage. And last of all, you can feed horses clamp silage. We fed horses clamp silage in trials in the UK, and after they get used to it, and they live on it and survive on it very well indeed. All of these fibres, though, whether it's grass or it's haylage or hay or whatever it is that you make your forage into, it's got to be free of weeds. It's got to be well conserved, and you've got to store it well as well. Some of the organisms that I spoke about yesterday, the allergens that cause coughing in horses, they grow in the storage conditions. So if the forage isn't stored properly, then you will get growth of things like aspergillus fungi, and that's an allergen and causes coughing in horses. So I've just introduced some of the forages there, that there's the choice of what you can feed. So somebody will ask me, what is the best forage? What is the best forage to feed? Well, there is no ideal forage. There's nothing I can't say to you, feed alfalfa or feed hay and all your troubles are behind you, because it very much depends on the nutritional profile. The best forage is the forage that suits what that horse is doing, the body condition, the energy requirements, how long it's spending in the stable, etc. All forages should have good hygienic quality, and by that I mean free of contaminants such as weeds and any toxic products, but also low dust if possible. And then we talked a little bit yesterday about feeding systems and time budgets. So whatever forage, if you have a horse that's spending a long time in the stable, then that will influence the type of forage you choose. Because you want a forage that the animal can spend a long time eating without getting too fat. So what influences forage quality? What influences the quality of the grass and of the hay and the haylage and indeed the silage? Well, first of all, the grass species. Ryegrass that I know you grow here has got a very high nutrient content. So it's high in sugars, it's quite high in protein at the early stage of growth. The physiological age is probably the most influential factor when looking at conserved forages. The younger the grass, the higher the proportion of leaf to stem, the higher the nutritional quality. And that's because the horse is able to digest and ferment more of it. It also contains more protein, and it contains more water-soluble carbohydrates and digestible carbohydrates. Then your growing season, it will influence how much sugar and fructans is in the grass. So you've got a lot of sunshine one year, you'll get high levels of fructans, less sunshine, lower levels of fructans. Harvesting conditions, how quickly have you been able to take it off the field, wrap it and store it correctly. And all of that will influence the airborne respirable dust content. If you have a horse that's coughing, then you need to be aware of not only the hygienic quality of the dust content, but try and find a source of forage that's got a high proportion of leaf to stem, that's young, that's high in nutritional value. Because we know, our research has shown us that the more mature and stemmy the hay, the dustier the hay. So not only is that good for the nutritional content, but it's also better for the dust levels. But the bottom line is there's no rules or standards that governs what forage is like. Each forage depends on all of these conditions, and these conditions alter from season to season. So looking at what we mean by the maturity and what are the substrates, if you like, that the horse has available to eat. Well, the structural carbohydrates, the plant fibres, are made up of three main constituents. We've got cellulose, hemicellulose, and pectins. The cellulose is composed of glucose only. It's actually beta-linked glucose molecules. And it's the way those molecules are held together that makes cellulose only fermentable. Starch is also just made up of glucose, but starch is alpha-1,4 linked molecules of glucose, and therefore it is digestible by the enzymes. So it's just how that glucose is held. Hemicellulose is made up of a range of sugars, and then pectins, which actually is the intracellular cement, are made up of these acidic sugars. Now, the actual names of them doesn't matter to you, except that just to say that these pectins make up the intracellular cement. These are potentially about 12 to 14% of the pectins are digestible in the small intestine. So pectins are what we refer to as soluble fibre. Pectins also act as a stimulant to the microbial population because it's easy for them to degrade, so they survive well on pectins. Then the primary cell walls, these are cellulose and hemicellulose. Primary cell walls are in the leaves, so it's the young, succulent part of the plant as well. And primary cell walls are largely completely fermented by the horse's hindgut microbial population. But then as the plant grows and it gets more mature and the seed heads start to appear and you get greater levels of stem in comparison to leaf, you then get higher proportions of glucose and xylose. Glucose and xylose together are indicative of secondary cell walls. And this is very, very fibrous. And these can be largely undegraded. So it's the access to all of these nutrients is dependent on the age of the plant. So if we look at how this physiological aging actually influences what we get in terms of our forage. Now, our early cut haylage, this is very young. It could be early cut hay. It's just it happens to be and has to be haylage here in the UK because we can't make very high quality hay. But this is a ryegrass, so it's very similar. Would be very similar to your early cut hay and high quality hay. Then our late cut haylage is more mature, so that would be cut when the flowers are just about appearing and you've got a higher proportion of stem to leaf. Our seed hay is probably a little bit closer to your oat hay that we discussed yesterday, where you've got the seed heads on there as well as the fibre. But the actual fibre part of it is very fibrous indeed, and some of these figures will show that. And then we've got meadow hay, which is a common hay in the UK, and it's made up of mixed species and generally is about medium, sort of reasonable proportion of leaf to stem. And then the lucerne hay, which you're all rather familiar with. Now this is just the dry matter content. If we look at the digestible crude protein content, you can see that actually the crude protein content in early cut haylage is high and pretty digestible. But once you go down to a more mature plant, that level plummets. So not only is there not that much protein present, but it's not very digestible either, because the protein is locked up in behind the cell walls. Then these would be variable depending on the proportion of leaf to stem and the age of each of these crops, but this is what makes lucerne such an excellent feed for young horses and for young growing animals, is that not only is the crude protein content quite high, but it's also very digestible. Now both the NDF and ADF are values that for looking at the fibre content. So our NDF is our cellulose and hemicellulose, and the ADF is just the cellulose and a little bit of lignin in there. And these just reflect the age of the plant. So as the animals, if we look at these figures, these two comparing figures here, as you get more secondary cell walls and more fibre, you can see how these levels, these values increase in comparison to the low-cut ones. And that means that not only is the level high, but it's less digestible. And that has a major influence on how well the animal can actually use that haylage. The water-soluble carbohydrates are also the sugar content. The sugar content is not very high in lucerne because lucerne actually stores starch. So it's a slightly different way of using the soluble carbohydrate or storing the soluble carbohydrate. Grasses store sugars, so they store fructans and sugars. But looking at the fibre content and the water-soluble carbohydrate content, that is all reflected in the digestible energy content of the forage. So the younger and more leafy the forage, the more the animal can digest it, the more energy and the more protein. We can also show that I just said earlier on there that the airborne respirable dust that I talked about yesterday is lower in early cut forages. And as you get to later cut forages, the dust level increases. So again, better for respiratory to go to the early cut forages. Similarly, with the mold levels very much and bacteria levels very much depend on conditions. And when we're looking at eating time then, the more fibrous the feed, the longer it takes generally for the horse to eat. So if you have a fat horse in the stable for a long time and you want to be sure that he's got something to eat for the day, then you choose a more fibrous and more mature type of forage so that he can spend long eating it and spend a longer time chewing it. I had a conversation earlier on with somebody about talking about horses that windsuck and crib bite, and they're saying, well, we put toys in the stable, but it's not stopping the crib biting. It's because it's the chewing response. Horses are designed to chew, eating for 16 hours in the day. So it's not just occupying them with doing things, it's eating time. They need to be eating. Yeah, it keeps cutting out on me.
Yes, it's cutting out exactly. Something's wrong. They have to fix it.
Yeah.
Yeah, because it's cutting out and then I don't hear you.
Yeah. No, I can hear it. Sydney goes. No. Okay, is that better?
Much better.
Okay, we'll try. So that's just a guide. You could do this with any foragers, just to look at the content and how the physiological age actually influences the content and the digestibility of the forage. So what sort of energy, how do horses get energy from forage? Well, the fibre is fermented in the large intestine to short-chain fatty acids. The main short-chain fatty acids are acetate, propionate, butyrate. And they are generally in this proportion. You can alter that proportion by feeding slightly different fibres, and you can influence maybe the propionate levels and the butyrate levels by 4 or 5%. But it's always 70% or so acetate, 15 to 20% propionate, and 10% butyrate. And you can see the amount of energy that each of these individual volatile fatty acids give the horse. So it's 10 moles of ATP per mole of acetate, 17 from propionate, and 25 from butyrate. The trouble is, they don't make much butyrate. So that is the raw fuel. That's what the microbial population yield after all the fermentation of the fibre. And then those are then metabolized in the energy production systems by the horse for energy in the liver and in the muscles. The fuel for aerobic energy production, 50 to 80% of it is used for maintenance. Even a horse working very hard indeed will not use more than 50% of his total ration for exercise or for other things other than maintenance. The other thing that's interesting about fibre is that up to 60% of the glucose is actually synthesized from propionate. Now, those of you that are training or interested in quarter horses, they run very short distances, very fast. Most of it is used anaerobic energy production, but some will use glucose if it's a little bit longer. And people are concerned then you can't feed fibre to these horses because where are they going to get their glucose from? Well, actually they make it. They make it from, it's synthesized in the liver from propionate. So your fibre will give the horse glucose, the necessary glucose to run the race. Muscle glycogen replenishment from high quality fibre also occurs quite readily. So again, that's something that until Essen Gustavus and co-workers did their work, everybody thought you're not going to get muscle glycogen from just feeding fibre. Well, actually, you do. The other nutrient, obviously, we're concerned about is the protein from forage. The crude protein content, as our table has just shown, is influenced by the physiological age and the soil nutrient content. But we must also be aware of the biological value. So we've just had a very good talk on protein, but looking at the amino acid profile, how much lysine is there, how much methionine is there, because you will only use the protein in the feed according to the amount of lysine and methionine that is present. And we also, and it's important for young stock, must ensure that the small intestine digestibility of protein occurs, because it's only protein that's digested in the small intestine that the animal can use for muscle building and everything else. But the protein in fibre also has a prebiotic value. Now, prebiotic is a feed that you give the hindgut or give microbes, and it stimulates them to grow better and to be more efficient. So some of the protein from the forage helps maintain a healthy microbial population. What other useful things are present in forage? It's potentially a very good and available source of minerals, particularly things like alfalfa, hay, red clover, early cut grasses and hays, such as haylage. For long-distance riding horses, some of these fibres will hold a reservoir of water. Hemicellulose and pectins actually hold water. And that water can be recirculated and used for thermoregulation during exercise. And in fact, Harris's work has shown that hay and salt, 73% more water and electrolytes than on a low-fibre diet. And dehydration is the biggest cause of fatigue in long-distance horses. Some people are concerned about the weight in the gut. Some of the wonderful photographs I was shown yesterday of your racing quarter horses, they're not terribly worried about weight. But in the UK, we're very worried about weight on the race horses. So there's a little bit of prejudice against the amount of fibre that you can feed. But it's a matter of balance. So you've got to choose again. It's not a matter of the right forage or the right conditions. It's the right thing for that horse at that time. The other thing that the fibre does is it is very good for the health and immune system of the horse. 70% of the immune system is held in the gastrointestinal associated lymphoid tissue. It is in you as well, by the way. Most of your immune system is held in your gut. And the body develops this gut microbial profile very early on. There's been quite a lot of interesting research done on babies where they've shown that babies that are born either naturally or by caesarean section have got totally different gut microbiomes. And so the same will happen with foals. It's the environment early on that will influence what's in their gut. Young stock also need to have highly available minerals to grow good, healthy bone. And that is what is in fibre. And the fibre in equine gut favours the gram-negative bacteria, and those are the bacteria that you want. Those are the good, healthy, fibre-degrading bacteria. So with all that in mind, a couple of years ago now, I was approached by an Irish feed company called Eclipse, and they make very high-quality grass haylage. And so we compiled what I call a fibre TMR, and by TMR I mean total mixed ration. So we took the fibre and we added various nutrients to it. I can't tell you what's in the feed, because if I did I'd have to kill you. So we have to you just have to believe me that it's all fibre and healthy. And in 2016, having formulated this feed, we fed it to 12 thoroughbred foals. Would they eat it? How would they grow on it? What would their joints look like? And would they actually eat it? Would they fight? What would happen? And we had some very good results in 2016, so that suggested that we should go on and do a properly controlled trial. So in 2017, we did what we call a matched pairs 4x4 trial. So that means we had 8 foals, and each pair born around about the same time so that they had the same growth trajectory. And we fed 4 of them this TMR, this total mixed fibre ration, and the others were fed a cereal and hay-based diet normally, as they would have been. And we measured the average daily gain, the height, the girth, and the behavioural observations. And this is what the feed looks like. So it's just a fibrous feed, and they tucked into it. They really liked it. And so we fed that to them in the creep outside, and then we continued to feed them that for some of the later ones when they came in the wintertime in the housing conditions. And these are the results from the trial. And the most important thing about this is I haven't presented all the height details, etc., because really what we're interested in is the growth rate, the average daily gain. And we can see on the fibre diet, they grew at 1 kilogram per day, and on the cereal diet, 1.1 kilogram per day. So no significant difference. So basically, these foals grew just as well on an all-fibre diet. Not a bit of cereal passed their lips. Okay, it was high-quality fibre and well-balanced, but it was an all-fibre diet. But most importantly, and particularly for thoroughbred foals, we get quite a lot of developmental orthopaedic diseases in thoroughbred foals. We had no joint problems in the TMFR group at all. So those that were fed all fibre diets had completely clean joints. They were also more chilled out. As a group, they were more relaxed and they weren't so aggressive and they weren't running around the field or the pen. So that is also good for the joints. So we were very happy about that. Why does it work? Why was it so successful? Well, it can be explained, but this is a bit of work I did quite a long time ago now. God, I really am getting old. And it shows the crude protein content. Now, this was what we call a gut partition study, and I did this with fistulated horses in Dijon in France. Do you know what I mean by a fistulated horse? Yeah? Does everybody? Will I explain it? Okay. So it's basically a hole in the side of the horse, and they put a cannula in, so it's a little tube, and it allows you access into certain regions of the gut. And these horses were cannulated at the iliocecal junction, so just at the interchange between the small intestine and the hindgut. So, and what we did with these feeds is we put them in these tiny little bags, little mesh bags. We stomach tubed them into the horses. And when they went through the gut, we collected them. They had magnets in them, and there was some sophisticated bit of equipment that allowed us to pull them out. And we could pull them out at the end of the small intestine. So we could see how much of each of these feeds, the protein in each of these feeds, was digested in the small intestine. And remember, I've just said it's the protein that goes in the small intestine that's important for the horse. And this is why the alfalfa, and this was a low-sugar water-soluble carbohydrate grass, so this was a high-quality grass. And you can see that out of the protein content, 19% and 21%, which gives you an indication of the quality of the feed, how much of it was actually digested in the small intestine. Now, up until this, we believed that protein just from fibre feeds went in the hindgut, and that was it. It didn't go in the small intestine. Well, some high-quality feeds, you do get protein going in the small intestine. So this is why these animals were growing so well on these high-quality diets. So it's the quality that makes all the difference. So briefly, what about working horses? Well, there's been some interesting work done in Scandinavia on looking at haylage, and again, for haylage, think of young leafy grass or leafy hay. That haylage can maintain the body weight of animals at 2.3% of their body weight. They eat it, they maintain it very well. But these exercising horses, and these were 2.5-year-olds trotting horses, and they actually showed that in comparison to a more conventional long fibre and concentrate diet, that they had the same velocity, they could run the same speed, they carried a little bit more body weight, but they had a more stable hindgut microbial population, and they had less undesirable bacteria. So all in all, these fibre-based diets will allow the animals to run if you choose the right fibre. It's all in the right fibre. Now, looking at the energy expenditure for exercise, this is another one of my PhD students who's going out monitoring hundreds of horses and looking, and he's using the Manfred Konin's indirect calorimetry equation to change heart rate into energy requirements. And interestingly, we all think our horses work a lot harder than they actually do. And so this is the digestible energy as a percentage of maintenance. This is the activity, and this is what the NRC suggests that animals need in this work and when they're doing this work category. Now, most of the work that my student has found comes in the light to early moderate category. Even the race horses that he is currently monitoring are not in intense work or not showing that they are using that amount of energy. So I think we're going to be read you a calculation of what actually animals' requirements are. Because most horses, in fact, only do light work. They might run very, very fast, and some of those quarter horses, I don't know how they move their legs so quickly. But they're only doing that for such a short time. And when you think of the overall energy budget, it doesn't actually require a lot of energy to do that. It's very intense and very short. So the classification of the work type and looking at your animals and saying, well, how much should I be feeding this animal, rather than I think it's working hard or not. And on the whole, if you have got some quality fibre, and I'm going to talk to Elias later on about making a nice fibre feed out of alfalfa and things like that, so that if you feed high quality fibre, there's very few horses do actually need additional cereals. Okay, you might find that really strange to hear me say that, but it's the case. So what are the quality fibres? Well, this is the form that we feed alfalfa in. The alfalfa's cut very short, and it's on a short cutting cycle, and it's high temperature dried, and so it's always of an even nutritional content. So it's very high quality. And most of our owners will bucket feed all of these fibres. So instead of giving cereals at breakfast, lunch and tea, they will give a fibre feed. Excuse me. And some of our feed companies now are producing pellets that are high fibre. So things like these high fibre cubes are like you would see out in the feed, like they look just like extruded feeds, only they're all fibre. They contain some soy hulls and some sugar beet and all sorts of processed feeds, but they are very well balanced. So these are the sorts of things that I'm looking at when I'm talking about high quality fibre. Horses with very high energy demands, those that can't seem to survive on just fibre, or indeed if you're in a situation where you can't actually get good quality fibre, then you are going to have to supplement a little bit. If you're only able to feed the hay or get the forage, that's the straw part of the oats or very mature, then you're going to need some additional energy. So you can add fat and oil to the diet, and I would do that before I would go for cereals. Now you can get these in high-fat rice bran, or you can feed liquid corn oil or soybean meal oil or linseed, cod liver oil, any of these things. In the feed that, I'm not giving away too many trade secrets, in the feed that we made for the young foals, we used quite a high proportion of linseed oil, because linseed oil has got a good ratio of omega-3 to omega-6 fats, and omega-3 fats are anti-inflammatory, and again that helps to reduce the incidence of developmental orthopedic diseases. If you do go into the feeding fat, then again, to maintain fat must be digested, must be enzymatically digested in the small intestine. So thinking of the rate of passage and the speed of food through the gut, we again recommend 1 gram of fat per kilogram live weight per meal. But that actually means if you feed lots of meals in the day, you can feed quite a lot of fat. But you shouldn't give too much too quickly, because otherwise it'll rush from the small intestine, it gets dumped in the hindgut, and it interferes with fermentation. If you're going to feed fat, again, it's not a wonder ingredient. You're not going to feed fat and 2 days later the horse is going to be out winning the race. It's a long-term process, because you need about 3 weeks adaptation for the animal to properly digest the fat and then to have the metabolic advantages such as glucose sparing from feeding high fat. So like everything in feeding, it's a long-term fix. It's not a quick fix. So in conclusion then, what would I recommend that you feed? will base the diet on a higher quality as possible long forage. Only for the fatties do you need to go for the low quality forage, so that they can spend more time eating and not putting on too much weight. But basically all horses, if they're fed high quality forage, will do well. Bucket feed HDF fibre feeds, HDF meaning highly digestible fibre feeds. Don't reach for the cereals, find some of these products that are chopped fibres or fibre-made feeds, and you'll find your horse will have a healthier gut. And for those that are high energy, reach for the oil first rather than going for the cereals. And I like to think of feeding as a pyramid. I start off with fibre, takes the largest part of the ration. That's the most, remember, if you turn the pyramid on its side, that's what we're looking at. This is the hindgut, this is the area that you should be feeding. And then, if you need higher energy demands, I would feed a little bit of fat and oil. And if that is still not quite doing what you need it to do, only then would I feed cereals. But I would feed these ingredients in this proportion, so more than a minimum really of 2/3 of fibre, and the rest of it divided between oil and cereals. So that's a little bit of a whistle-stop tour through some of the fibres and the reason that we feed high quality fibre. Thank you for your attention, and I hope I haven't made you as bored as I made this donkey. Thank you.
Preguntas. ¿Alguien tiene preguntas? Un minutito, digo unos segundos. ¿Lista? Ok.
Voy a hacer la pregunta en español. ¿Ok? Hace un rato, en una de las ponencias, se hizo una pregunta: si era posible alimentar a los caballos solamente con forraje, y se habló de caballos de carreras. La ponente dijo que no era posible, que había que dar cereales. Yo creo que esta es una pregunta que está aquí en el cuarto para todas las personas que están en el área de caballos. Yo no soy del área de caballos, ¿sí? Muchos de ustedes ya lo saben. Yo soy del área de rumiantes, y en rumiantes sabemos que los ácidos grasos volátiles son fundamentales para la energía del animal. La vaca produce leche gracias al ácido propiónico. Si la vaca puede... A ver, ahora, sí. Si la vaca puede producir leche con ácido propiónico, ¿por qué no puede correr el caballo con ácido propiónico?
It can.
It can, that's right. Sí se puede. Sí se puede. Yo creo que esta es la conversión que necesitamos. Aleluya. ¿Sí? Sí, sí se puede. Me gustaría que usted comentara un poco más sobre esto.
Okay, I think the work of my colleagues, let me see if I can go back to it. It's gone. Sorry. I think the work that I was talking about earlier on, that my Swedish colleagues did, these were feeding racehorses. These were 2.5-year-old trotting racehorses that maintained the speed and the body weight and had more stable guts than those horses fed on concentrates. It is, we suffer, it's not only here, we suffer in the UK from the same thing. It's tradition, and we believe that horses can only make glucose from cereals. They'll only make it quickly enough from cereals, and that's what they need, because forage doesn't have enough energy, doesn't have enough nutrients in it to sustain work. But it does, it really does. But it has to be high quality forage. I would agree with the person who said, if you're feeding low quality hay, very stemmy hay, this is why I talked earlier on about the secondary cell walls, so that you understand what I mean by quality in the hay. So if you feed very fibrous forage, your horse cannot race, can't do a lot on that sort of forage. He will also, on low quality forage, he will be short of other nutrients as well. He will be short of protein, he will be short of minerals. As my table showed, it's the age and the fibrous content has a knock-on effect for all the other nutrients. So, how many people in the room make their own hay? Does anybody make their own hay? Do you know farmers close to you or people who make hay that you can influence? Okay, good. So now it's up to you. It's all up to you. You've got to go and say to them, and say to the horse owners, we will pay you more for your hay if you make it higher quality. So you cut it at this height, you get less, you don't get as much weight and as much hay per acre, but it's higher quality. It's much better. And so if you can persuade people to do that and pay a little bit more for higher quality forage, it will improve the situation. Is that okay?
Aquí.
¿Alguna otra pregunta?
Sí, aquí.
¿Dónde? No te veo. Oh.
Buenas tardes. Una pregunta. En el añadir aceites, ponen la misma categoría el aceite de maíz o el aceite de linaza, que son creo que los dos aceites que tenemos disponibles en México. Quisiera saber en cuanto a calidad cuál es la diferencia, ya que en mi opinión poner aceite de maíz sería añadir también carbohidratos y sería proinflamatorio, es lo que en mi experiencia, a diferencia del aceite de linaza, que sería básicamente proteína, ¿no?
No, linseed oil is not the protein. Linseed oil is just the oil from the linseed, but it has a different fatty acid profile. So linseed oil is higher in omega-3s, so is anti-inflammatory. Corn oil can be, for young animals I wouldn't necessarily recommend it. For older horses it's okay. It has a higher omega-6 to omega-3, so can be pro-inflammatory. But in terms of energy, all the oils are round about 35 megajoules of digestible energy per kilogram. So in terms of actual energy, and that's all you're getting out of the oil, you're not getting any protein or anything else, it's just the oil. So this is not soybean meal, it's soya oil. So it's the oil that's extracted. Okay.
Sí, gracias por su gracias por su plática y comentario. Donde en uno de los ranchos donde vamos a trabajar siembran X número de hectáreas y de hecho las praderas tienen ryegrass, maíz y en algún momento sí, junto.
Mixed.
Y lo han inclusive implantado con alfalfa, entonces creo que es una mezcla bastante eficiente. Son caballos de polo tienen un rendimiento y desempeño, es uno de los ejercicios más extenuantes para un caballo. Y suplementan con aceite de linaza en algunos casos y con aceite de aguacate.
Well, that's an oil I hadn't thought about.
Sí, es un poco caro.
I don't know the profile about avocado oil. How mature is this crop when they cut it?
Cortan 2 o 3 veces.
Okay, so it's quite leafy and quite young.
Sí.
Yeah. So that's good. You've got the answer. They don't feed any cereals.
Prácticamente no.
Give this man a medal. Give this one. Okay. That is what you should be doing. And polo is quite hard work. It's probably not as hard work as we think, but there's a great example. That fibre and fat, you've got the job. Yeah. Yeah.
Quiero oír sus comentarios sobre el uso de un ensilado hecho de 33% de cada uno de los 3 ingredientes que son maíz, alfalfa y avena.
So is the corn whole crop? So it's the grain and the plant.
Está listo para usarse como ensilarlo.
It's the cob. It's the
Es
cob.
la planta completa de maíz.
Oh, it's the whole plant.
Yeah.
Yeah. Well, the corn will give you high energy. So it should be quite high energy. The alfalfa is the protein and good mineral balance. And what else did you say? Ryegrass. Oats.
Oats, alfalfa, and corn.
Not quite sure why I would put oats in that mix.
Solamente porque es la costumbre en el estado de Querétaro de hacer este tipo de silo.
Yeah.
Sin ningún fundamento, hasta ahora que queremos identificar la calidad del ensilado.
Yeah. The only thing that I would say the advantage between oats, or the difference between oats and maize, is that oats is about 80 to 90% digested in the small intestine. So I think I showed a graph about that yesterday. It has quite a high glycemic peak, and it's very digestible, so it's very accessible energy. Some maizes can actually not be that digestible. So some of the early work done by Helmut Meyer in Germany showed that some of the corn was only digested, or maize was only digested to about 40%. So I would really have to see the crop, but if there's quite a lot of grain, or it's a little bit more mature, then probably that part of the feed could only be digested in the hindgut. Whereas part of the oats, so the oats have got the grain and the plant part, so it's whole crop, yeah? Yeah. Then that would be, a good proportion of that would be digested in the small intestine, so that would be fast release energy. But in a better way than feeding it just as grain. So, yeah, it seems like an interesting mix, and yeah, I'd like to see it. I've got to come back to Mexico, come and see all these things.
We are going to have you as a visitor in order to give us a hand to have a master thesis for a student here in the vet school.
Yes, good idea. Let's talk.
Quisiera, bueno, me quedé un poquito con la incertidumbre del doctor Rosiles. Realmente la mezcla es para ensilar. Y ella hizo el comentario como si fuera una mezcla de ensilados independientes. El problema con este producto es que es un enhilaje que está mezclando cereales y leguminosas que tienen patrones de fermentación totalmente diferentes. Y es muy común encontrar de pésima calidad y de regular o buena calidad ese tipo de producto. El tema creo es que ella entendió que la mezcla es independiente de los ensilajes y no, este producto los mezcla y hace un enhilaje. ¿Sí? Entonces eso es muy diferente.
Yes, I understood that.
Okay. Y precisamente con el tema de ensilajes, preguntar si los patrones de fermentación que esperamos para el caso de cereales pequeños es muy parecido a lo que debemos esperar en el caso de maíz, o es algo, o tenemos que buscar algo específico.
When you say small maize, you're talking about the maize of grains, small grains. So yeah, okay. No, really, the small grains that you're feeding, you shouldn't be thinking about that in terms of fermentation. You should be thinking about that in terms of digestion in the small intestine. So that is different. What the last question about the comment on the three composition and haylage, I understood was all together. And I can see why maybe you take some out and you've got more maize in one handful and more oats in another handful, and it might be a variable quality. But when things go into the digestive tract, even in my total mixed feed ration, there were different ingredients. And it's not all fermented at the same time. Once things go into the gut, they do separate out according to the speed at which they are digested or fermented. So you will find that some of the ingredients, some of the maize and the alfalfa will be pushed through into the hindgut, whereas maybe some of the oats or some of the grains from the oats will be digested in the small intestine before it reaches there. So just because a feed is made up of different components doesn't mean that the way the horse deals with that is an average of all of those three. The moment it goes into the gut, it is separated out, and the animal deals with it about where it's going to digest it. I can understand how getting all of those three things together at the right quality might be a little bit challenging. I mean, I'd love to see it to make it a good evaluation of it, and I would like to analyse it to see how fibrous it is, or what the water-soluble carbohydrate content is, what the starch content is, etc. Then I could make a much more valued comment on it.
¿Ninguna otra pregunta? ¿Una más? ¿Ya? Bueno. ¿No? ¿Ya no hay preguntas? ¿Todo claro? Bueno, pues hemos concluido esta ponencia con la doctora